A very good morning to Dr. Day. I'm Tiong Yong. Today I'm going to present my FYP proposal with the title Fabrication of Photocatalytic Fuel Cell using titanium dioxide. PFC is a system which used to degrade the organic matter in polluted water and also generate electricity. In PFC system contain three key components which are cathode, anode, and aqueous medium for electricity conduction. Anode and cathode electrode is connected with external circuit. The anode is coated with semiconductor photocatalysts like TiO2 and zinc oxide. Light energy captured by semiconductor TiO2 and cause the photoexcitation to form electron hole pairs at photoanode. This will cause the oxidation process of hydroxide ion to hydroxyl radical at anode. The electron transfer from photoanode to cathode will cause the reduction of oxygen to superoxide radical ions and produce electricity. This superoxide radical ion is reactive oxygen species which is intermediate for the removal of the organic pollutants. The organic pollutant chosen is polymer as it is one of the biggest waste in Malaysia. Polymer is very difficult to treat because it has very high BOD and COD value. The problem faced nowadays is the fossil fuel as the main energy resource will be finished very soon. PFC has potential to replace fossil fuel to generate power and electricity. So to optimize the power generated, many research are focused on PFC system. The objective of the research are to construct the PFC using titanium dioxide as the photoanode to treat polymer and to study the power generated for PFC under optimal conditions. From the research, there are many factors affect the performance of PFC. The first factor is light source. PFC will have greater performance under sunlight compared to UV light. It is because of the recombination of electron pair is easier occur under UV light. The next factor is molecular structure of organic pollutants. The number of releasing group in pollutants like sulfonic group increase the PFC performance. Dissolved oxygen also affect the PFC performance. The higher the DO concentration will have the higher electric generated. Next is the fuel cell design. Large thin electrode and P-type titanium dioxide nanotube array is designed to provide bigger surface area for absorption. The next factors are supporting electrolytes. The supporting electrolyte with highest negative charge at ion will generate more power output. Another factor is pH conditions. The PFC show highest power output at the range of 6.4 to 8.4 due to the 0 point charge of titanium dioxide. Next, closed circuit PFC produce higher output because superoxide further oxidize the organic compound in closed circuit conditions. Output power increase with the concentration of the pollutants until certain concentration decrease. According to the research, KOH is the most suitable supporting electrolyte in PFC to treat polymer due to the high mobile hydroxide ion. And the voltage increase with the concentration from 0.1 to 0.3 molar but drop at 0.4 molar. And the most suitable pH condition is at 0.3. Methodology of the experiment start with preparation of the titanium dioxide electrode. Carbon from pencil is called sol gel solution of the titanium dioxide solution using deep coating method. This is my PFC system set out. In this experiment, supporting electrolyte, dilution ratio of polymer and also the initial pH condition is studied to optimize the output power. First type of the supporting electrolyte which are sodium chloride, sodium sulfide, and magnesium sulfate, is added as changing variables. Supporting electrolyte is added into 800 ml of dilute polymer solution with a dilution ratio 1 to 400. The photoanode and cathode are fully immersed in the solution for 1 hour and the initial resistance that is 100 kiloohms. The reading is recorded with reduced resistance that varies from 100 kiloohms to 1 ohms in the 1 hour time. Current density, power density, and field factors will be calculated using the equation stated. The supporting electrolyte which get the highest output will use in the next steps. Next, the experiment is repeated with the dilution ratio 1 to 400, 1 to 200, and 1 to 100 of polymer as the changing variable under same condition. Next, a PFC will be set up based on the optimal dilution ratio and polymer and the supporting electrolyte from the section above. The PFC will be studied at different pH conditions from pH 2 to 8. The pH value of the solution will be controlled using the concentration sulfuric acid and sodium hydroxide solution. In conclusions, the performance of PFC using titanium dioxide as the photoanode under the optimal condition based on type of supporting electrolyte, dilution ratio of polymer, and pH conditions are determined in the end of the research. And that is all for me. Thank you very much.